Good morning, dear students. In the previous classes, we discussed about vector algebra. So that is about the vector algebra. So we discussed about vectors, scalars, vector products, and all those things. Now we have to discuss about 3D coordinate system. 3D in the sense, three-dimensional coordinate system. So generally, these three-dimensional coordinate systems are classified into two types. So it was classified into two types. The first one is left-handed 3D coordinate system. I already told you 3D in the sense three-dimensional. So second one is right-handed 3D coordinate system. So in the first one, left-handed 3D coordinate system. So what is the left-handed 3D coordinate system? Let us take our left hand. So we have to choose your thumb in upward direction, thereafter forefinger to the right hand side and middle finger to your face side. So what is that? Thumb means upward direction, forefinger to the right hand direction and middle finger to your face direction. So this is the way we have to keep our left hand. So then what the fingers will show? So see this finger, that means middle finger will show x-axis, forefinger will show y-axis and thumb will show z-axis. So this is so that means the middle finger actually it was showing towards to your direction. So it is not possible to draw a line towards to your direction, so that I have gave some inclination for that towards to your left side. So that how we can able to draw that coordinate system. So x-axis towards to your left side, y-axis is generally same and z-axis is generally same. So actually the x-axis it was towards to your direction from this tree. So it is not possible to draw a line like that. So this is the left-handed 3D coordinate system. Now we are using this left-handed 3D coordinate system. Let us discuss about the second one, right-handed 3D coordinate system. So now we have to take our right hand. So this is the way how to keep our fingers. So thumb in the upward direction, forefinger to the left hand direction and middle finger to the face direction. So this is the way how to keep. So how the x-axis, the middle finger will give the direction of the x-axis and the forefinger will give the direction of y-axis and the thumb will give the direction of z-axis. So here also it is not possible to draw x-axis to your direction. So I give some inclination to the right side. So in the previous one left side, now this one right side. So this is the way I draw. So this is the right-handed 3D coordinate system. Now we are not using this right-handed 3D coordinate system. Few people almost forget about this right-handed 3D coordinate system. Just we can discuss this 3D coordinate system in the classification only. So all the problems we are doing now with respect to the left-handed 3D coordinate system. So no problem, you can able to do all the problems with respect to right-handed also. It will give the same results. But few complications will be there with the right-handed 3D coordinate system. So here y-axis to the left side is positive, there y-axis to the right side is positive. That is the same complication. So we already made all problems by using the left-handed system now. So in the middle we cannot take the right-handed 3D coordinate system. So we have to follow the left-handed 3D coordinate system. Nobody using this right-handed 3D coordinate system. So we have to discuss about the left-handed. The next one is three-dimensional coordinate system. The major types. This is the types you have to write in the examination. So you need not to write those left-handed as well as right-handed. So mainly these coordinate systems are three types. The first one is rectangular or Cartesian 3D coordinate system. So I already told you 3D in the sense three-dimensional. So So rectangular or Cartesian. Rectangular, we can call it as a rectangular, otherwise we can call it as a Cartesian 3D coordinate system. The second one is cylindrical 3D coordinate system. So here it was cylindrical 3D coordinate system. So third one is spherical or polar 3D coordinate system. So you can call it as a spherical 3D coordinate system, otherwise polar 3D coordinate system. So in that, the first one is rectangular 3D coordinate system. So in 3D coordinate system there must be three axes. Here it was x, y and z. How the x axis will be, how y axis will be, how the z axis will be, we can see here. So the x axis will be like this. So x axis will have both the positive as well as negative values. Similarly the y axis. So y axis from right to left, from right to left. So right side is positive and the left side is negative values. For x axis, screen to your side, that means from screen to your side it was positive axis, from screen to back side it was negative axis. So next one is z axis. So upward direction positive value, downward direction negative value. So this is the way we can able to represent a rectangular coordinate system. So what a coordinate system must follow? If you collect any two different axes, the angle between them must be 90 degrees. What is that? If you collect two different axes, the angle between them is always 90 degrees. So let us take the positive x and positive y. What might be the angle between them? So it was 90 degrees. So similarly, let us take y and z. So what is the angle between them? It is also 90. So z and x, it is also 90. You take any two axes different, not the similar one. So x2 minus x, it will give minus 180. x2 minus x means 180 degrees, minus x2 x means minus 180 degrees. So it will be different. So if we have to collect two different axes, definitely the angle between them is 90 degrees. So take minus y x, the angle between them is 90. So any two you can take, it will be 90. So this rule must be followed to make a coordinate system. So any two axes can make 90 degrees. So this is the rectangular 3D coordinate system. So if you want to know a brief or complete about 3D coordinate system, you need to know about the planes those are existed in coordinate system. What are those planes? Those are existed in coordinate system. Next, incremented volume. What is that? Incremented volume. And then unit vector, those existed in this coordinate system, and their dot product and cross product. Unit vector and their cross product and dot product. Thereafter, conversation. What is that? Conversation. So thereafter, the maximum limits of the coordinate system. These 5 things you need to know if you want to know about a 3D coordinate system. So first we need to discuss about planes. So later we can discuss all these 5 things in detail. So the first one we need to discuss about the plane. So what is meant by plane? So let us say the z-axis as a constant value. So now I am taking z is equal to 0. Z is equal to 0. I am only varying x and y. Then how the plane will become? So this is the plane it will become. So this is the plane that was occupying by only x and y. And here the value of z is equal to 0. So this plane can be called as xy plane. What is the plane name? Xy plane. And it is also can be called as z is equal to 0 plane. Here, what is the value of z? Z is equal to 0. So it is also can be called as z is equal to 0 plane. And so now we can make x value is 0. So before that we need to know one more thing. So what is the direction vector that is perpendicular to the xy plane? So what is the direction vector that is perpendicular to the xy plane, and otherwise you can also call this direction vector as the direction vector of xy plane. So what is the direction vector of xy plane? So that is a z bar. So the surface is seeing towards to z direction. So if the surface is seeing towards to z direction, the direction of the surface is z axis. That means z direction. If the surface is seeing to your direction, means the direction means x axis. So let us discuss that also. So now let us make x is equal to 0. Then vary y and z. Then how the plane will become? So this is the plane. So now here x is equal to 0 and we are only varying y and z. So then this plane can be called as, so it was only occupied with y and z, so it can be called as yz plane. So it is also can be called as x is equal to 0 plane. So why? Because all the x values in this plane is 0. So what is the direction vector for x is equal to 0 plane? Nothing but ax bar. So the unit vector for the direction of xy plane is ax bar. So why? Because the yz plane is always seeing x axis. So the plane which sees will give the direction. Okay. So next one. Now we need to make y is equal to 0, so that we have to vary x and z. So we have to talk in sequence z and x. So then what will happen? So this will happen. Now we are taking y is equal to 0 and varying only z and x. So this plane can be called as zx plane. So we have to talk in sequence. So xy, yz and zx, not xz. So xz is out sequence. So zx plane, and here the values of y is equal to 0, hence it is also can be called as y is equal to 0 plane. And what is the unit vector that is perpendicular to zx plane? Otherwise, the direction vector of the zx plane is ay bar. So that is zx plane is always seeing, always watching the y direction. So it can be called as ay bar. So this is about plane. So what we need to know in a rectangular 3D coordinate system: incremented volume, unit vectors and their products, conversions, and maximum limits. So next topic is incremented volume. So these 5 things we have to know if you want to know about a 3D coordinate system. So now we discussed about the plane. The next one is incremented volume. So before going to the incremented volume, you need to know about differential change. What is meant by a differential change? You can write dx. What is meant by dx? You can write dy. What is meant by dy? You can write dx by dy. What is meant by these things? So what is meant by differential change? So let us take an x-axis. So both positive as well as negative values. I will take a very small change in x-axis. So which can be called as dx. That means dx means in x-axis it was a very small change. So dx is a very small change in x-axis. It is almost equivalent to the point, not completely exactly equal with point, but almost equal with a point. So that very small change in x-axis can be called as dx. So now after that we need to discuss about differential length, differential surface and differential volume. How these will be, let us see. Let us place a point. Let us take so many points. So place one point on the above of other point, thereafter third point on the above of already placed 2 points. So then what will happen? It will form, just see what it will form. So this is the point, one after another, placing one on another. Then it was what it was forming? It was forming a line. So that means a smallest change in the line is nothing but a point. That means if you cut the lines into pieces, the minimum piece can be called as a point. What is that? If you can able to cut the line into pieces, very small pieces, the smallest piece can be called as point. So it is also can be called as differential length, and it is almost equal with a point. It's not completely exactly equal with point, but it almost equals with a point, and this can be called as differential length. A very small change in a line can be called as differential length. Similarly, now you place a point and another point. So similarly, now you place a line and another line, and thereafter another line. So what will happen? Just see. So lines are placing one above another one. It was forming a surface. If you place a line above the another line, so it was forming a surface. It was forming a rectangular surface here. So that means the smallest change in the surface is nothing but almost a line. The smallest change in a surface is nothing but almost a line, and it can be called as differential surface. So it can be indicated with dl. Differential length can be indicated with dl. So if you can take x, it will become dx. If you can take y, it will become dy. If you can take z, it will become dz. So differential surface. If the surface is formed with x and y, it can become dx dy. If it is formed with y and z, it will become dy dz. If it is formed with z and x, it will become dz dx. So similarly, all the surfaces. Okay. So the very small change in surface can be called as differential surface. It is almost a line. So now we can take a surface, place a surface on another surface. What will happen? Let us take so many papers, A4 size papers. So place a A4 size paper and take another A4 size paper and place it on the previous one, and take another one and place it on the previous one. What it will form? It will form a book-like shape. It can be called as volume. So that means a very small change. So let us take each paper as a surface. So then it will become a volume. So that means a very small change in volume will be a surface. So see here you can see. I am placing the papers like surface one on another. So that what will happen? It was a differential. So a very small change in a volume can be called as differential volume, and it was almost a surface. It was almost a surface. So this is about the differential change. So this is very important to identify incremental volume, so that I discussed about this topic. So now the topic is incremental volume. So let us take our x, y, z, only positive values here I am taking. So the positive values is enough for identifying the incremental volume. So let us take a point P, x, y, z in rectangular coordinate system. So now I have to represent this point with respect to x, y, z. So that what I have to do? So I have to draw a parallel line to the x-axis. That is, the end of the line must be project the point. So this is the way I have to write. So that means if I project the torch light with respect to the z-axis, that point must be coincides with x-axis. So you can see that afterwards you know that. So I draw a line. So it will have the length of xy, because p x component is in the point p, x component is x. So the length is x here. Similarly, draw a line that is parallel to y, the length is y. So now z, the length is z. So now that means if you can able to project a torch light with respect to z axis on the point, definitely it will coincide with x, y, x and y. So that in that way you have to draw the line. In that way you have to draw the line. So by doing similar simple problems, you can easily draw this type of points, no problem, easily. Okay. So now I want to make a rectangular box by using this point. How can I able to make it? So let us take the lines, those are parallel to z axis at the end of y as well as x. So similarly, parallel to x axis to the top of those z. Similarly, y. So this will form a rectangular box. So then what is the volume of this box? So the volume of this box can be identified as the bottom area into height. What is that? The bottom area into height. So what is the bottom area? So the bottom surface is in xy plane. So that was occupied with x length and y length. So the area of that rectangle is x into y. So the bottom area is x into y. So and then what is the height here? From x plane, how much height that point contains? Z height. So x, y into z will use the volume of this box, this rectangular box. So x, y, z simply you already know, I think. So now how to identify the incremental volume? What is meant by incremental value? So let us take a very small change in the x direction from the point P. So from the point P, you can take a very small change in x direction. Let us assume that dx. So I already told you, that's why I discussed about the differential change. So a very small change in x direction will give a differential x dx. Similarly, a very small change in positive y direction will give a dy. Similarly, in z direction, positive z direction will give dz. Now I have to form a rectangular box by using these three lengths. So this is the rectangle I can able to form. So it was formed by dx, dy, dz. Now if I can able to identify the volume of this formed rectangular box, it can be called as incremented volume. Why? Because the x is incremented in dx way and y is incremented in the direction of y, that was dy, and similarly the z is incremented in the direction of z, that is dz. So now I need to identify the volume of this box. So we know incremented volume is equal to dV. So that means already discussed about differential volume. Incremented volume here it was dV. So dV can be identified the bottom area into height. So if you want to identify any rectangular box or anything, so you need to identify the bottom area. Thereafter you need to multiply that bottom area with respect to height, so that you can get the volume. So what is the bottom area here? So this is the bottom area that was occupied with dx and dy. So it was dx into dy. So and then what is the height? It was dz. So then volume will become dx dy into dz. So dx dy into dz, and it will give dx dy dz, and it can be called as incremented volume. So what is the use by identifying this incremented volume? So by knowing this incremented volume, we can be able to identify any volume in xyz coordinate system, that means rectangular or Cartesian coordinate system. How we can see that? So if you want to identify V, we have to take the left hand side T to the right hand side. Then what will happen? If left hand side D you can take to the right hand side, that must will become integral. So D will become integral if you can take left to right. So here how many integrals we have to take? Here there are three variables x, y and z. So that it will become triple integral. So V is equal to triple integral of dx, dy, dz. So how we are able to identify the volume of that given bottom box that was formed with x, y, z. So here the x is varying from 0 to x. So I am taking the value x is varying from x is equal to 0 to x. So y is varying from 0 to length y. So y is also varying from 0 to y. So z is also 0 to z. So there also I am taking z is equal to 0 to z. If you substitute these values here, you can able to get x by z. Can you check it? So first you can do integral dx. Integral dx means x. So x, what is the limit? 0 to x. That means upper limit is x, lower limit is 0. So for x, upper limit is x, so it will become x, minus lower limit is 0, so it will become 0. So that means x minus 0, it will give x. So that is the result of dx. So what will be the result of integral dy y? Y minus 0, it will give y. So x into y. So what is the result of dz? It will give z. So x, y, z. So it is possible to identify any rectangle that was formed by rectangular coordinate system if you know the limit. If you know the limit, here we know the limit 0 to x, 0 to y, 0 to z. If you know the limit in number, you can able to identify any volume by using incremental volume. So this is the advantage of incremental volume. So what is the next one? Unit vectors. So unit vectors in rectangular coordinate system. So let us take the positive values of x, y, z here again. So no need of negative values here. So now if you can able to collect unit length in the direction of x, and if you can able to give the positive x direction, then that vector can be called as unit vector in the direction of x. So here this, let us assume that is the unit length vector in the direction of x, which can be called as ax bar. So the direction vector of x is ax bar. Similarly, the direction vector of y is ay bar. That means ay bar contains unit length in the direction of y. So similarly, az bar. So now we have to make dot product between any two of these unit vectors as well as cross product that can be called as, so unit vector cross product as well as dot product. So we need to identify them. So that will be useful. So first we can discuss about dot product between each two. So first we can do with the similar vector. So you know the dot product. So here what we know, unit vector means what is the magnitude? Unity. So here we know the magnitude. So what is the angle between x and y? 90 degrees. So we know the angle. So that we can use this formula. So a bar dot b bar is equal to modulus a bar into modulus b bar into cosine angle lying between them. So here what are the unit vectors we are collecting? Just we can collect first similar vector, thereafter different vector. So first similar vector. That means ax dot ax bar. That is equal to magnitude of ax bar into magnitude ax bar into cos angle length between x and x. So angle length between x and x. So what is the magnitude of ax bar? 1. Magnitude of ax bar 1. So the angle between x and x is always 0. X and minus x, it will become minus 180 or plus 180. So here it was x and x, it will become 0. So cos 0 is equal to 1. So 1 into 1 into 1, it will give 1. So ax dot ax is equal to 1. So if you can able to take ay, the same result it will give ay dot ay, magnitude of ay into magnitude of ay, and the angle between y and y same 0. So it will also give 1. So ax bar dot ax bar and ay bar dot ay bar and also az bar dot az bar will result unity. So if you make the dot product between the same vectors, it will give unity. It will give unity. This thing you need to identify from this point of view. So next one, you can make different vectors, how it will become. So let us take the same formula. Now I can take ax dot ay. So again the same unit vector. So 1 into 1 into, but what is the angle between x and y? 90 degrees. So it was, so cos 90 is 0. So 0 into anything? 0. So if you can able to make dot product between two different unit vectors in a same coordinate system, the resultant answer is 0. So x dot ay, that is equal to ay dot az, that is equal to az dot ax. Two different vectors, that means any two different vectors will come 90 degrees, cos 90 is 0, so the answer is 0. So here it is the dot product obeys the commutative law. If you make the reverse thing, that means ay dot ax, Similarly, az dot ay. Similarly, ax dot az. The same answer will give. So if you can take the reverse, this is also same answer, 0. Why? Because cos 90 is 0 always. This is about the dot product. So the next one is cross product. So now we can take the similar vectors first. So we know the formula cross product a bar cross b bar is equal to modulus a bar into modulus b bar into sine angle line between them into a n cap. So we need to identify the a n cap by using right-handed screw rule. Okay. So ax bar cross ax bar for similar vectors. So magnitude of ax bar into magnitude of ax bar into sine angle line between them dot a n cap. So now we need to identify a n cap. First, before that, we need to see the result of sine angle. Thereafter we can able to find it. So what is the answer here? 1 into 1 sine 0. So similar vectors means the angle between the similar vectors is 0. So sine 0 is 0. 0 into anything 0. So no need of finding a n bar here. Okay. So answer is 0. If you can able to multiply, cross multiply the same vector, the answer is 0. If you can able to multiply the same vectors in dot product, it will be unity. But here it was 0. So a bar cross ax bar is equal to 0. So similarly, ay bar dot ay bar and az bar dot cross az bar will give 0. So the cross product between the same vectors will give 0. So the cross product between the two different vectors. So now correct ax bar cross ay bar is equal to. So now it is need to identify a n cap, otherwise a n bar. So why? Because it here. So ax bar modulus x bar is equal to 1, modulus ay bar is equal to 1. So the angle between x and y is 90, so sin 90 is equal to 1. Now we need to identify the a n cap. So how can you able to identify a n cap? So here you are making the angle from x to y. X to y. So you are rotating from x to y. So what we have to take? So place a screw on the z axis. On the z axis. Now we have to rotate that from x to y. That means anti-clockwise direction. X to y means anti-clockwise direction. So anti-clockwise direction means the screw will go in the upward direction. Screw will go in the upward direction. So what is the unit vector lies in the upward direction? That is az bar. So a n cap is az bar. So this is the way we need to identify a unit vector that is perpendicular to the plane that is in xy. Already we discussed about the direction of xy is a z bar in the previous one. So now also the same one. So I will tell a simple technique without using a screw rule. I will tell that. No problem. So here the angle is making from x to y. So we have to rotate the screw in anti-clockwise direction. Anti-clockwise direction means upward direction. So upward direction in vector is az. So a n cap is az. So 1 into sin 90 also 1. So 1 into az. So it will give az bar. So ax cross ay will give az bar. So similar way, ax cross ay will give az. Ay cross az will give as. Similarly, az cross ax will give ay. So we have to remember this is sequence x, y, z. So y, z, x and z, x, y. So this is the way we have to remember. So otherwise I will show this cycle. So ax, ay, az and again ax. This is the cycle we have to remember. So if you follow this cycle, it was in sequence. If you doesn't follow this cycle, it was out sequence. So let us take ax cross ay. So the remaining vector is az. So answer is az. So ax cross ay, that means that is in sequence. So answer is az. So let us consider ay cross az, that is out sequence. Then the answer is minus az bar. So So suppose let us go with AZ AY, AZ cross AY. So that is out sequence, then the answer is minus AX bar. So let us take AZ cross AX. So now that is in sequence. So that is clockwise direction in sequence. So AZ cross AX is AY, the remaining vector AY. So without confusing, just draw this circle. You can able to identify easily without knowing that right-handed screw rule. This is the best way to identify the result of two cross products, two different vectors. So this is the way AY cross AX bar is equal to minus AZ bar. Similar way AZ bar cross AY bar is equal to minus AX bar. Similar way AX bar cross AZ bar is equal to minus AY bar. So this is the way you can able to identify the cross product between two different unit vectors. So what is the next one? We need to identify conversion. So how we can able to convert? So conversion means you have to convert if you know two coordinate system. One is rectangular coordinate system and the other one is cylindrical coordinate system. If you know the variables here is x, y, z, there will be some other variables, some other three variables. If you know one variable, if you be able to convert that variables into another rectangular coordinate, another coordinate system variable, that can be called as conversion. So what is that? If you know the one coordinate system variable, if you can able to convert that variable as another coordinate variable, that can be called as conversion. Now up to now you know only one coordinate system. So we need not to talk about conversion. So if you know the another coordinate system, then we can talk about conversion. So you need not to talk about conversion because you know only one coordinate system. So the next one is maximum limit. So next one is maximum limit. So let's take this rectangular coordinate system again. So I need only the positive values. So by varying the x and y and z, if I need to occupy the universe, what will be the x value and y value and z value? That can be called as maximum limit. What is that? If you can take a small rectangular box, if you can increase that by using certain x limits, by using certain y limits, by using certain z limits, if it can, that rectangular box can occupy whole universe, then that will be the maximum limit of this rectangular coordinate system. How it can able to occupy whole universe? So see, if you can able to take the x-axis keep on increasing from minus infinity to plus infinity. Similar way, y-axis is keep on increasing from minus infinity to plus infinity. And similar way, z-axis from minus infinity to plus infinity. So that rectangular box can occupy the whole universe. So that means what is the limit here? X-axis from minus infinity to plus infinity, y-axis from minus infinity to plus infinity, and z-axis from minus infinity to plus infinity. So in this way you can able to occupy the whole universe by using a rectangular coordinate system. So these are the maximum limits you have. Okay, so this is about the rectangular coordinate system. We all discussed in this. That means planes. Next one, incremented volume, unit vectors and their products, dot products and cross products. With similar vectors as well as different vectors, and thereafter conversions. So here you know only one coordinate system, so no need of conversions here. So then maximum limits. So the next one is cylindrical coordinate system. Cylindrical three-dimensional coordinate system. In the next class, we can see those things. Please, dear students, write each and everything. Okay, so this will be very, very useful for you. Thank you, dear students.